for the bonus on the PUBG problem, we'll make our table again, but since we're only dealing in Y, we'll just deal, because we're only solving for stuff in the Y, I'll mostly fill out the Y side of it, but I will still draw the X because it's important to get into the habit of drawing these out. See the change in X, change in Y, acceleration in the X, acceleration in the Y, initial in the X, initial, final in the X, initial in the Y, and final in the Y. Now, since we are at halfway, where we've only gone 90 degrees through the jump, we need to half the time. So this really equals the time over 2, which gives us 1.45 seconds. I'm sorry, that looks bad. Let me just fix that. It's 1.45 seconds. Change in X, well, since we only want to find how high he's gone, we don't need to deal with this side of the table. So we don't know the acceleration, but we do know the initial velocity, which we found before, 15.4165 meters per second. But we know that the final velocity is 0 because right as he's at the peak, he's completely stopped changing in either way. He's waiting to start accelerating downward again. You know, the acceleration is completely canceled out this part, the upward velocity, and is now switching to pull him downward. So if we're going to need to solve for acceleration. So using the formula, V final equals V naught plus acceleration times time, 0 equals 15.41 plus acceleration times 1.45. Working this out, you get that the acceleration in the y direction is negative 10.665 meters per second squared. Then, to work out the change in y, we'll just use our standard change in x formula. Change in y equals v naught t plus 1/2 at squared. Change in y equals v naught 15.4165 times time, 1.45, plus 1/2, acceleration, negative 10.6. I'll, in the calculation, use the whole thing. I'm just doing this for space, times the time, 1.45 squared. On plugging that in, you get that the change in y at half point, so the apex of his jump, the highest he was from his starting position in the y direction, was 11.14 meters. There you have it. That's working at the apex of the projectile. So yeah, this was a good basic understanding of projectiles and how they work. I hope this helped you learn in Mr. Scavarci's class. Thank you.